Welcome to the conversation. I'm Ariane, and I will be your host for this first segment. I am, of course, joined by Jared, our resident astronomer, as well as Mike, our rocket specialist. And we also have a Dada behind us who is going to be producing the show. Now, today in news,
the European Space Agency finds a little extra data a little extra close to a comet.
And Lockheed Martin presents an update to their Mars base camp proposal.
our main topic today will be a roundtable discussion all about Elon Musk's keynote at this last week's International Aeronautical Congress that was held in Adelaide, Australia, and featuring special guest commentator Dodd the Everyday Astronaut. And of course, in our last segment, we'll be discussing your comments and questions about last week's show. This is Tomorrow Orbit 10.36.
Good morning. How's everything up in the sky?
I want to make sure I give a huge thank you to our Patreon supporters. These are of the escape velocity variety. These people, every last one of them have given us $10 or more for this particular segment of this particular episode, and also so much more. Thank you. I really cannot thank you enough. You, of course, get your name in the show, access to exclusive Patreon-only hangouts, and so very much more. If you are also interested in getting this kind of special thank you from us, all of us here at Tomorrow, head on over to patreon.com/TMRO. All right, Mike, we have got so many launches, and I know you speak fast. You probably don't speak nearly as fast as I do sometimes, but that's okay. We're gonna go ahead and get started because there's 4 of them we got to get to, and we got a huge show we got to get to. So why don't you go ahead and start us off with one of our favorites, the United Launch Alliance launch.
That's right. United Launch Alliance successfully launched a rocket after several delays, and this was a classified payload for the United States National Reconnaissance Office.
7, 6, 5, 4, 3, 2. We have ignition of the RD-180 main engine. 1. And liftoff of the United Launch Alliance Atlas V rocket carrying the NROL-42 mission for the National Reconnaissance Office.
So this launch occurred at 5:49 Coordinated Universal Time from Space Launch Complex 3E at Vandenberg Air Force Base on Sunday, September 24th. Now, this Atlas V was in the 541 configuration, which means that it has a 5-meter payload fairing, a single-engine Centaur upper stage, and 4 side-mounted solid rocket boosters. But since the payload, the NROL-42, was a classified payload, not much is known about the satellite and its functions. And United Launch Alliance cut short the launch broadcast shortly before the payload fairing separation, but before the first stage separation. And even though we don't know what NROL-42 is, the professional speculation says that this is probably the second satellite in the new 3rd generation of electronic signals intelligence gathering, or rather signal interceptions, and is informally part of the Trumpet program. And they also believe that there is an instrument on board that is part of the space-based infrared system as well. We don't have any confirmation of that, and it is just speculation, but whatever this mission was, United Launch Alliance performed their part of it with a successful launch in a very good way. And also our own Jared Head was there to witness this launch and collected some awesome footage himself. But in the interest of time, we want to show that to you guys, but we're going to have to wait until after dark for that, just because we have so much to talk about this week.
So very much. Speaking of which, we had an AsiaSat launch as well.
Yeah, this was a commercial launch from the International Commercial Launch Services of a Proton M launch.
4, 3, 2, 1.
We have ignition and liftoff of the ILS Proton launch vehicle with the AsiaSat 9 satellite on board.
Now, this launch occurred at 1852 Coordinated Universal Time on Thursday, September 28th from the Baikonur Cosmodrome in Kazakhstan. And you may remember a couple of weeks ago that ILS launched a communications satellite built by Space Systems Loral for Hispasat. And that was the Amazonas 5 mission. This mission, the AsiaSat-9, is also a communications satellite built by Space Systems Loral and is pretty much an identical mission profile as the Amazonas 5 mission as well, where the Breeze M upper stage burned a total of 5 times over a 9-hour period, and it released the AsiaSat-9 satellite into an elliptical geostationary transfer orbit that had a low point of about 4,045 kilometers, or 2,513 miles, and a high point of 35,786 kilometers, or about 22,000 miles, and an inclination 23.4 degrees relative to the equator. Now, AsiaSat-9, which is designed to last 15 years, will relay direct-to-home television broadcasts, video programming, satellite radio, and broadband data signals across a coverage zone over the Asia-Pacific region, stretching from the Middle East to Australia. And this is going to be the last commercial launch of the Proton rocket this year. There's only one more Proton launch scheduled this year in December, which is going to be for the Russian government. And then after that, another commercial launch for the Proton M early next year. So very cool to see, and interesting that it had a very similar profile to the last mission just earlier this month.
Yeah, totally. Which is good because sometimes, the big joke is, oh, all launches look alike, and they do to a certain extent, but they really don't. No. But this one did. So there's that. Okay, so to keep you marching right along, there was also a long, no pun intended, Long March 2C launch. Man,
that was great.
That was good, and I didn't intend it. Go ahead. What's the next one, Mike?
Yeah, and I'm really excited about this Long March launch. This was kind of one of their smaller launches, but China has had 2 launch failures that have delayed a lot of their rocket launch plans for 2017, including a lunar mission that was supposed to take place later this year. But this was a successful launch, but due to it being a military launch, there's not a whole lot of footage. So, unfortunately, that's what we have to deal with for this. But what we do know about this mission is that the payload were 3 satellites for the Yogan 30 mission, which is collecting electromagnetic detection and related technical tests for the upper atmosphere, and probably relaying some other information for the Chinese military as well. The launch took place at 4:20 Coordinated Universal Time, and here it is.
That's all that yellow smoke that always freaks me out.
Yeah, very toxic, very toxic. That was from the Xichang Satellite Launch Center in southwestern China, and hopefully with this successful mission, China will begin launching other successful rockets other than the Long March 5, which was the one that failed back on July 2nd, and be able to continue with a lot of their other plans. But one thing that I'm a little bit happy about, just because of my nationality, is China's going to have to catch up in launches if they hope to beat the United States, which is now ranked #1 in the amount of launches so far this year. They'd have to launch over a dozen satellites to catch up. So that's kind of something that I'm a little prideful about, just because I'm an American.
I was going to say, that felt like a challenge accepted, is what I just heard. Goodness.
Come on, China, try to beat us.
They
I just want to see more launches.
Yeah, no, exactly, right? Just anything to get more launches. Speaking of more launches, we do in fact have one more. There's an Ariane 5 launch.
That's right, that's right. And this was another one of those launches where they were doing a dual satellite launch for this as well. And this launch, it was actually supposed to occur earlier this month, but the launch was aborted at the last second. Now, they're launching 2 United States-built communications satellites. The first payload, Intelsat 37E, was built by Boeing and is going to be bringing broadband and wireless communications over the Americas, the Atlantic Ocean, and Europe. The second payload, BSat 4A, is going to provide HD, 4K, and 8K Ultra HD television over Japan for Broadcasting Systems Satellite Corps. And here's the launch.
3, 2, 1, top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 239.
So liftoff of this Ariane 5 rocket occurred at 21:56 Coordinated Universal Time on Friday, September 29th. The rocket performed as expected, and we even got to see some ground views of the solid rocket booster's separations. Now, after Ariane 5's second stage sent the Intelsat 37E and BSat-4A spacecraft into an elliptical transfer orbit, placing the satellites into an orbit that had an apogee or a high point of 35,700 kilometers or 22,000 miles, and a perigee or a low point of 249 kilometers or only 155 miles, but had an inclination 6 degrees relative to the equator. And both of these satellites were deployed successfully, and a member of the Ariane launch team confirmed that the rocket reached its near perfect orbit and that the BSat 37E and, Intelsat 37E and BSat-4A separated from the launcher on time, 29 minutes and 45 minutes into the flight, respectively. So everything was successful for this, and it was actually a pretty quick turnaround from their successful static fire test earlier this month.
Yes, we do love a successful static fire.
Yes.
Oh goodness, if you missed it, that was go back just a couple more episodes, and then that will be.
You'll get it.
You'll get it.
Yeah, go back to episode 10.34 and you'll know what we're talking about.
Yeah.
All right. So then, Jared, we'll make you speak for a little while. Thank you, Mike, by the way. You have a surprise.
Yes, surprise everybody. Actually, it's a surprise from the European Space Agency, kind of to everyone who wants to use the data. They've been poring over the last bits of data that came back from their highly successful Rosetta mission, which was to comet Churyumov-Gerasimenko, or 67P, if you don't want to call it that. Or sometimes the ESA people call it Churi-Uri, which I kind of like.
Oh, that's amazing.
About that too. But they got a surprise in the telemetry data. While they were going through it, the data specifically just before Rosetta touched down on the surface of 67P back in September 2016, they found packets of data that were from Rosetta's imaging instrument suite known as OSIRIS.
Just dropped anywhere for anybody to see and find?
All of a sudden, there it was. Now, they put all of these packets together and kind of massaged the data a little bit, and they were only really able to get about half of the quality out of it that they could have gotten if it had been delivered correctly. But this image was taken after the last original image that was received. So this new image, it's not any higher resolution. 1 pixel is about 2 millimeters of area, and this visible area that we see right here is about 1 meter by 1 meter. So like my waist to ground, I guess, is how big this is.
Which they can totally see on camera,
yes, they
so that's
can,
good.
at the moment. But because this is an extra image, and we didn't expect to receive this, this now means that we have twice the amount of data from this close to the surface of a comet. And, I mean, this doesn't really sound like much, but when you consider the fact that these are the only 2 images that have ever been taken this close to the surface of a comet before, kind of a big deal. Now, the European Space Agency also put out this really cool graphic right here, which is actual imagery from Rosetta showing you the original last image in that yellow box compared to the now newly surprisingly found last image in the red box. The X is where Rosetta landed at, and this is also to scale as well. This is showing you just how big Rosetta is compared to those areas that the images came from. So some really nice stuff coming from the European Space Agency from a mission that was over a year ago, but here we are now, still apparently grabbing images from it.
That's really cool.
Yeah.
That's very, very cool. Thank you. I appreciate that.
Yes.
It was kind of reminding me of, oh man, now I can't remember the name of that game where like you bury something and then you have the coordinates and somebody else has to go find the coordinates and you get like a small little trinket. And
Geocaching. Geocaching.
Geocaching. Thank you. It was like geocaching on asteroids. I'm not sure what that would be called. It's like a new thing, but that's what that reminded me of immediately.
It's a very elite game.
Very, very elite game. Right
Yes.
now, ESA's winning. All right, Mike. So I assume you've had something to drink, maybe sat down for a minute or two. Why don't you go ahead and tell us a little bit more about Lockheed Martin? A lot of things happened at the International Aeronautical Congress, and we're going to get to one of the big keynote things, but a lot of other interesting things happened. This is one of them. Why don't you go ahead and tell us what happened?
Indeed. So at the International Astronautical Congress, Lockheed Martin presented updates to their Mars Base Camp proposal. And there's actually some really cool pieces to this and some new pieces of hardware and how their whole plan aligns with the Deep Space Gateway and a new Mars lander as well. So the whole thing about this, though, is that the Mars Base Camp is not a surface base. It's actually an orbiting base, but it's not quite a space station either. It would feature a core node module that would have cupolas that are supplied by ESA, and it would be the hub by which two large living spaces are connected with plenty of windows to enjoy the experience for the astronauts inside. It would also have modular fuel tanks, large commercial solar panels, solar electric propulsion, habitats that also serve as protection against radiation, Orion capsules, and cryogenic upper stages that are probably going to be ACE's upper stages that would complete this whole station. But there's also some new pieces, as I said, that have been presented too. The ways that Mars Base Camp is aligned to support NASA's proposed Lunar Deep Space Gateway will be for developing and testing systems, including Orion, and traveling around in cislunar space, but also doing telerobotics and helping to learn how to protect astronauts who will live and work in orbit around the moon away from the protection of the radiation, from the protection of the magnetic field of Earth from radiation, excuse me. Now, on the Gateway and eventually onto their Mars Base Camp, they would be able to perform science and test out all of these pieces of hardware and first test out this entire system at the Deep Space Gateway before going on to Mars. And with this, there's a really cool new piece of hardware where they would extend out what they call the excursion module that would be equipped with two special MMUs, or manned maneuvering units, that would be able to go to the moons of Mars, Phobos or Deimos. And those MMUs would have these spider legs that would allow an astronaut to crawl around the surface of those asteroid moons so that the astronauts could collect samples. I just think that would be so fun. I want to be that guy who gets that job doing that. That would just be amazing.
That's neat.
But also following this, though, their whole architecture plans for a new surface lander, and it kind of looks a little familiar. The concept is designed to be a reusable single-stage lander that would be able to descend to the surface of Mars from orbit, from that that Mars Base Camp. And each surface mission would last about 2 weeks and only have up to 4 astronauts. So this is not the size of the BFR that we're going to be talking about later, even though it looks kind of similar. And it would be returning back to that kind of orbiting space station, the Mars Base Camp, where it would be refueled and ready to go for another mission. And it looks to me more like a combo between SpaceX's BFR and the old DCX experimental rocket, and also a little bit of the Dragon 2 capsule. It kind of reminds me of Dragon 2 because of the nose cone on the front of it, which opens up to reveal the docking ports. And with that, it's just a little interesting to me. But during the testing or regular operations of this lander, Lockheed wants, or rather could use it on the moon as well. And even though it's designed for aerodynamic reentry, the engines are capable enough to complete a lunar landing, especially of the lander if the lander starts from the Deep Space Gateway in a near lunar orbit. In any case, this whole plan aligns a lot with NASA's most recent proposed exploration missions, where they would be building the Deep Space Gateway piece by piece and then test out Mars technologies around the Deep Space Gateway and test out the Mars transit spaceship around there before ever undertaking a Mars mission. And even though their Mars Base Camp's spaceship could provide an extra level of safety, there's a lot of other cool things about it that align a lot with how NASA wants to move forward with their Mars plans in the future. However, the big difference between this and SpaceX's plan is that SpaceX's Mars ambitions would generally be funded by themselves. They're looking for ways to be able to pay for that. Whereas Lockheed Martin's plans, they would mostly be relying on NASA or other government agency customers to pay for this sort of plan to happen. And if no money comes forward, then the plan won't necessarily happen. And there's a cool image of it on the lunar surface as well.
Yeah.
Not that one, but the one right before. But anyway, this is kind of a cool idea, and whether or not it will actually happen, depends on if someone will pay for it. But in any case, I think it's still a cool presentation and gives me ideas for stuff in the future, even if it's just something to build in Kerbal Space Program. So.
Yeah, right? Everything can be done in Kerbal Space
Well,
Program.
it worked in Kerbal.
That's right.
Not sure if you
That's
knew.
right. Do all the things.
I heard collecting underpants is not a viable payment option, but maybe
it's also not a viable sample return.
That's
either,
really too
so.
bad. It's really too. See, we all get that. We all laugh. I don't understand why nobody else laughed at that one. Anyway, we have the one picture that we thought was for Mike's story that's actually for Jared's story coming up in this story. They looked really similar, honestly. Jared, why don't you go ahead and tell us what that picture was all about?
Well, that's no moon. That's a dwarf planet.
Aha!
Over 2 years ago, New Horizons flew by Pluto, and we're still making new discoveries from the data that we got back from that flyby. And one of those is that this terrain that you're seeing right there is actually these giant blades of methane ice. Now, scientists were initially confused as to how these things could form on Pluto, but now we know that they're actually extremely similar to structures in ice that we see here on Earth. I'll bet at an order of magnitude larger on Pluto. And they're called penitentes, and here they are. Here's some in Chile. They're sort of these ice blades that form when water ice here on Earth at high altitudes actually sublimes. Instead of evaporates. And this process works exactly the same on Pluto as it does here on Earth. Except on Pluto, it's not being done with water ice and water vapor, it's being done with methane. Now, these areas on Pluto that have these blades, which, forgive me for not telling you how big these are about 15 feet tall in this image right here. The ones on Pluto are anywhere from 200 to 400 feet tall.
Oh.
A lot bigger, most likely because Pluto's gravity is a lot less, so you're able to make larger geological structures, if you will, on Pluto. Now these blades appear on Pluto in areas that are concentrated with methane. So if you look at the top chart right there, that's a topographical chart, and that circle where all the red is at, showing the extreme altitudes, that's where the blades are at. On the bottom, it's a composition chart, and that circled area is where all the blades are at, and you'll notice that it's kind of orangish, and that's where that orange is indicating that there's lots of methane in that area. Now, scientists have been able to hypothesize what the side of Pluto not facing New Horizons at closest approach should appear like, and because you can see right over there to the right of it on your screen that there's lots of orange in that area, well, they hypothesize with some accuracy that there is likely giant bladed terrain in that area as well. So you might have an the entire southern hemisphere on one side of Pluto that we didn't get to see up close is likely that giant bladed terrain. So really, really cool to see what are called penitentes spread out all over half of the southern hemisphere of Pluto.
Interesting. As Tim Dodd, the Everyday Astronaut, who is hiding out in our chat room right now, is saying, Pluto's like the ultimate Lego, just don't step on it.
Yes.
And we also have a question from the chat room. So, Jared, methane ice or methane gas in the atmosphere?
Okay, so it starts as methane ice on the surface. It sublimes out to methane gas because there's not enough pressure there to develop liquid methane. So it just goes straight from a solid to a gas. And then when Pluto goes far away from the sun, it becomes cold enough that Pluto's atmosphere actually refreezes to the surface. So it goes through what we call deposition, which is when you go from a gas to a solid and you skip the liquid state. Again, not enough atmospheric pressure on Pluto for liquid methane to exist. So so it starts as ice, turns into a gas to make that very thin atmosphere around Pluto, and then when Pluto moves away, it deposes back into ice, and that's when the penitentes form. So,
Gotcha.
Yeah, very cool stuff.
No pun intended there either.
Yes.
All right. So we have a very exciting roundtable coming up. So what we're going to do is we're going to go ahead and head into break. And when we come back, we're going to be talking all about Elon Musk and international IAC and all of those things and what they all mean. Oh, stay with us. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination, and nothing in her way will keep her from her destination.
And welcome back to Tomorrow. Now, before we get into our segment today, a roundtable about Elon's presentation at IAC 2017, we first want to thank our patrons of Tomorrow. These folks have contributed to the show today that you are watching. We've got our Escape Velocity variety who give us $10 or more per episode. They get really cool stuff like access to our Patreon-only hangouts, early access to After Dark. They get to see a rundown copy of our show as we're building it, our swag store, voting rights on upcoming roundtable discussions, our Escape Velocity Discord channel. They get a lot of stuff. And of course, we can't forget our Orbital patrons as well. These folks give us anywhere from $5 to $9.99 for each show, and they get their name in the show during the second and third segment of the show. And they also get a whole host of nice goodies as well that you can take a look at. And if you'd like to take a look at some of the goodies you could get and you're thinking about contributing to the shows of tomorrow, head on over to patreon.com/TMRO. And we appreciate all of the support that you guys give us. We really can't do this show without you guys. And it's amazing that we can do everything that we can, and it's amazing because you're enabling it and allowing us to do that for you. So I'm Jared. I am the resident astronomer of Tomorrow, and I have got two guests via Skype from different parts of the United States, different time zones and everything. It's just absolute madness here in the studio right now. Of course, we've got Tim Dodd, the everyday astronaut, who's closest to me, and Space Mike, who's attempting a high five with Tim Dodd.
I didn't see it.
Screen, so it's okay. You guys can get it a little bit later in the show.
Takes practice.
Today, or you could just do it right now. Oh, yay! Now, Kith. No, I'm just kidding about that. So we're talking today, of course, about Elon Musk's presentation at IAC 2017, which was essentially a check-in of the plans that were given out originally at IAC 2016 last year, which you were at, Tim.
Yeah.
Very exciting place to be with that as well. So why don't we just go ahead and get right into it with probably one of the most, well, Elon said this was the most important thing about the presentation, which is that they think they have figured out a way to pay for all of this to actually occur. And that's sort of a very important thing, as they said in The Right Stuff, no bucks, no Buck Rogers. So it's the decider in what you're going to be doing. And the plan is to make Falcon 9, Falcon Heavy, and Dragon redundant. So in other words, they're going to take the newer, larger rocket, which is currently codenamed BFR, and they're going to use it to replace all of the current offerings with this new hardware. But is ending Falcon 9 and Falcon Heavy and Dragon actually going to do that, or is something else needed to actually pull that off? And I'm going to go ahead and start with Space Mike, and we'll go to you, Tim. And I just want to hear from you guys about that. So go for it, Space Mike.
Well, there was a couple of different ideas that they talked about in this presentation for how to fund it, but going to your point of whether or not it's a good idea to make redundant the Falcon 9, Falcon Heavy, and Dragon, I think that the ideas that SpaceX and Elon are having are that they still want to keep those vehicles around. They want to have vehicles that they can either at least refurbish, if not completely reuse, and have those in their inventory and reuse them as much as possible until they have to retire those vehicles or have some sort of catastrophic failure with one of those vehicles. So that those would still be around for, customers who don't want to use their BFR or, just don't need that capability. They still want to have something around that would be able to pay for that and still have their regular business plan in place. So I'm not sure about whether or not that's going to be enough. I get where he's coming from of wanting to move their resources for building the BFR within SpaceX away from, Falcon 9, Falcon Heavy, and Dragon and towards this BFR concept. But whether or not once BFR comes online, if their plans for how to use it are going to be enough to not only pay for the development of the vehicle, but also their more ambitious plans of going on to Mars and starting the first colonies. So,
all right, Tim, how about you? How do you feel about the plan that they have?
Well, one of the biggest things that people ask me, is why doesn't SpaceX like reuse the second stage? Why aren't they doing all these things with the Falcon 9 vehicle? And a lot of it comes down to the margins. There just aren't margins available in the current fleet of vehicles to be able to recover hardware to make it so you could launch a significant payload. And this gets over that big fundamental challenge. BFR is so big and so powerful that no matter what, it can launch literally any satellites, any number of satellites, dozens of satellites at a time, while still recovering every bit of hardware. So to me, that's the big, it's a fundamental change. It's not, they will pay for it because their profit margin can be infinitely increased almost. They can, if they're bringing back everything and all they have to do is light refurbishment, some checkouts and refuel the thing, I mean, game over. Look, they can launch satellites so cheap then because it'd be so routine, and that's a different type of vehicle than we are currently seeing online anywhere. And it's different than the space shuttle. It's different than any other system ever put forward. So, and it gets to that point where the margins, there is enough room in performance to be able to put a significant payload into space, into orbit, and come back down. And that's how they're going to do it, is by having a vehicle capable of full reuse.
Yeah, my big question mark with the financials of the presentation is that there weren't any solid numbers thrown around, and that I'm always a little leery when there's not a lot of solid numbers being thrown around. But one of the things I also was wondering about is this going to enable a market that is currently not enabled by simply the ability to throw a huge satellite into geosynchronous transfer orbit, or maybe literally directly inject a gigantic satellite into geosynchronous orbit. So those were some of kind of my questions about that. What do you guys think about a market enabler? Do you think that this is going to develop the market for something like that, or is it just simply going to end up being a bit of a not necessarily a toy, but it's going to be very specialized and ending up only really used for, say, directly throwing things to Mars? Who wants to take that? Anybody want
I'll
to
go
take
ahead. I'll start. At the end of your
Tim.
question, you said, is this good for only a vehicle for Mars? And I think that's the whole point of them scaling it the way they did, is they see use for it in the rest of the marketplace. The original BFR concept, or the ITS, or however you want to say it, from 2016, was pretty solely focused on Mars and Mars colonization specifically. And then this year they come out and they go, look, if we just kind of scale it to this, it would have some relevance in the current workforce. We could launch, and don't forget, we're starting to launch hundreds of satellites at a time. Look at India. I think SpaceX has one planned to launch a proverbial butt ton of satellites as well, like 100 or something at a time. Think about the BFR being able to take up 10, they'll take up the whole SES constellation at once. That could bring the cost down immensely. So it'd be servicing the current needs of the marketplace, is what I see it doing. It'd be different. It'd be a different outlook. It wouldn't be, think about if satellites don't need to have their own, they don't have to get into geostationary orbit. Normally a satellite is put into geostationary transfer orbit, where over months it actually raises its perigee and gets into its geostationary, or its final destination. What if it didn't need that? You could bring the cost of that satellite down immensely and just have enough for station keeping, enough propellant for station keeping, and then the cost might even be cheaper too. So it will just, that's how I see it changing. That's how I see, yeah. Mike?
With their whole satellite concept, and I believe that they released kind of an idea of what that might even look like, I think that the hope with SpaceX is that if they build it, the customers will come. Right now, the only very, very large payloads that even exist or even being built today, are from the big 4 government agencies that are doing space operations. And, there might be a very large satellite in the works, once every 10 years. So I feel like that for a very large object, that there's not going to be a whole lot of businesses that they're going to enable because it's only going to be the big four. However, I might be completely wrong about that, and having that sort of capability for a very large spacecraft or a very large satellite would enable companies to build something, multi-purpose and something that would be able to fulfill their needs. That might inspire a new market. But as for what markets already exist, I see a lot more, just like Tim was talking about, of them launching multiple satellites at once. And imagine if they did have, a really interesting geosynchronous transfer orbit where they could be launching out all of these different satellites on one mission, just like you're saying, and have an entire constellation of geostationary satellites in different positions, in different latitudes and longitudes, so they're covering different parts of the Earth. And why stop there? Why not set up communication networks at Mars or the Moon or anywhere? And I feel like with the presentation last year, their working name was ITS for Interplanetary Transport System, and they said that mostly we're going to want to go to the Mars with this, but we could also go to the moons of Saturn or Jupiter or other interesting places. And it was focused mainly on interplanetary outside of the Earth-Moon system. And I feel like the presentation this year is to include all of the things to try to generate as many interested customers and as many possible missions as they can to do what their end game is, which of course is getting to Mars and setting up the first colonies.
Yeah,
So.
and one of the proposed payloads that I was very excited about with BFR was flying a 8-meter monolithic mirror space telescope into space, which is under study right now. It's called At Last, and this is something that's going to happen in the 2030s. But of course, the astronomer in my head goes, "Why make it 8? Let's make it foldable in 20." So there we go. So enabling, potentially enabling things in the future with that there.
And to kind of go back to the whole redundant question, with this whole BFR, they want to replace the Dragon capsule as the cargo transport system for the International Space Station, maybe even crew rotations to the International Space Station.
Mm-hmm.
And it looks pretty big, and some people thought this might be a little humorous. But I mean, the space shuttle was pretty large, and I don't see a problem with this. It doesn't really look weird to me at all. So
yeah.
If they are able to do that, and of course have it affordable and be within the parameters of the contract they already have with NASA for delivering cargo and crews, then yes, this could be an enabler for that and earn them the income that they need to do their further ambitions.
So Destructor 1701 in the chat room has a really great question that I want to bring up, which is, what about this redesign makes the BFR better suited to all of these non-Mars applications? So what is it about the rocket that was presented this year as opposed to the Interplanetary Transport System from 2016 that makes it better suited for non-Mars applications?
I'll take a swing first. I don't think it's better suited. I think we were now sold the idea. They presented ways where they can use it for multiple things. I think they could have easily done this with the last concept. But quite frankly speaking, I think the big reason we're seeing this version come out first is because they can physically build it in Hawthorne, and they could not have built last year's in Hawthorne. It would not have fit. So it's more
from
of like
12
here
to 9 meters is just simply a matter of, do we have enough room in our hangar, if you will?
Yep, they can physically fit a 9-meter vehicle out the doors in Hawthorne, and they couldn't have built a 12-meter vehicle. So I think that's a big portion. It's like, think about how much money they'll save if they can continue to move and actually build this at Hawthorne as opposed to building it and building a new place somewhere else.
Gotcha.
And Elon said that they'd already ordered the tooling that they would need in order to make a 9-meter version of this as well. So that's in the works as well right now.
Yep.
Yeah, very cool. And speaking of tooling, anybody can plan a mission. I can go and give a talk about how I'm going to get 5 to 10 tons to the surface of Pluto easily, but it's only when you really start actually like bending the metal and forming the composites when we at least like to start taking things a little bit seriously. And SpaceX has a carbon fiber tank that they've tested to their maximum pressure. It holds 1,100 tons of cryogenic propellant. They tested it above flight pressure. In engineering, you test things till they fail, so that's a perfectly reasonable test that was occurring there. Also want to note composites holding cryogenics, which is something that has sort of been like a holy grail of rocketry since the 80s. In addition to that, they have 1,200 seconds of test time on their new Methalox Raptor engine, which is beautiful. I'm a big fan of mock diamonds, so this definitely delivers. And of course, SpaceX also has a fair amount of experience with propulsive landing, which is their proposed way of how they're actually going to land on Mars, both braking from atmosphere, just simply from drag, and then propulsion terminating that energy coming in down towards the bottom. So is this enough? At the moment, or does SpaceX still have a lot more to learn? Because they are building the hardware, but do they need a little more experience in certain areas? And let's start with Space Mike on this one.
Well, with the redesign of the spaceship itself, which is essentially a capsule and an upper stage, but as the same piece of hardware. I mean, Elon brought that same metaphor to light, but with it, the way that they've designed the engines is that with its new size and weight, that it would be able to do all these type of different landing scenarios, whether it be landing on Earth, landing on the moon, or landing at Mars, or potentially even more places. But the more ambitious stuff might be the next version of whatever this might be. And this might not even be, this is probably most definitely not the final version of this that we will see before they have something actually flying. And they have 4 very large vacuum Raptor engines and then 2 smaller sea-level Raptor engines. And even mostly those sea-level engines, the 2 smaller ones in the middle would be used. The previous version had 3 engines in the center and 4 of the 6 of the vacuum type Raptor engines. But even if one of those sea-level engines fail, one of them would still be enough to complete lunar and Mars landing scenarios. I don't know about Earth landing scenarios, but it would still be enough to be able to accomplish those goals. And I feel like even at the moon, even if both of those engines failed, they might even be able to use the vacuum engines to be able to do that successfully. I don't see why not. But whether or not this will be able to be successful and whether or not it's going to be better than the current systems they have and whether or not they need experience on this, in my personal opinion, I wish that they would make one version before doing any of this BFR stuff, which would literally be making a tiny BFR made out of a Dragon capsule and a Merlin, the Merlin engine using an upper stage of a Falcon 9. And that would be the true kind of concept that SpaceX and Elon, presented years ago, where they would try to reuse their upper stage of the Falcon 9 rocket. Why not do something like this right now with the Falcon 9 or the Falcon Heavy to learn those technologies needed to have your upper stage in spacecraft and do all of the landing scenarios that you want to do with that first? I would like to see them do that.
How about you, Tim? What do you want?
Well, I have to disagree right there already because that's one of the if they have confidence to go ahead and start producing these carbon fiber things at 9 meters and start actually making something to scale, why not do it? With Falcon 9,
the one that they built is 12 meters. That's for the original interplanetary transport system. So they can, if you could do it at 12, you can scale it down. It's
9 is scaling it down.
It's not impossible.
So we can look back in history at SpaceX. They went from the Falcon 1, and originally they were supposed to go Falcon 1E, which was a more powerful Falcon 1. Then they were supposed to do a Falcon 5, which was they're like, oh my gosh, we're gonna make this thing crazy powerful with our Falcon 5. And then at some point, when they actually secured funding for COTS missions to be able to do CRS resupply missions, they actually ended up getting enough money that they go, screw Falcon 5, we're going Falcon 9. And that's after they had only launched 4 rockets, 3 of which failed.
Yep.
So they had really no experience. They had no right to build a Falcon 9. You know what I mean?
Yeah, I mean,
in
Elon
a sense,
said
it's like
that they couldn't get people to want to work for them at that time. So
Yeah, I mean, I think it's kind of like they had no hope in the world of having Falcon 9 work, really, almost. It was a complete pipe dream. They went from this little tiny 500 kilogram lifting vehicle, the Falcon 1, and then they built this absolute workhorse that they use today, that they've made their soon to be US monopoly almost, that they've based everything off of. And I think this is them taking that exact same leap of faith into yes, they have a lot of stuff they have to figure out. These cryogenics and carbon fiber is terrifying. They probably know as best as anybody with the Amos 6 explosion. That was due to carbon fiber buckling under cryogenic conditions, you know?
Yeah, and the triboelectric effect. So
they literally, they literally learned more than anybody else at the time, you know, about that. And so they're going to have to apply these types of things on a scale that no one's ever seen before. But I think it's the right move, because if you can get it to work, you know, they might experience a failure. They might experience 2 failures on this new vehicle potentially. Who knows? But you might as well go for it at this point. And it'll probably continue to evolve, just like the Falcon 9 has evolved for the past, 6 years or whatever. It'll continue to evolve as well. But I think they're taking I think they're doing it right. Go big or go home. Especially with New Glenn and eventually New Armstrong coming online from Blue Origin. I think this is them saying we got to step it up. We can't get comfortable.
Oh yeah, pressure makes the diamonds, and it makes the mock diamonds too.
I was just thinking that.
There's our chat rooms actually brought up a couple interesting things that I feel like SpaceX has a genuine amount of inexperience at, and it's currently disadvantages their current plans. Which Jazzthrow says, what do you think about the absence of simulated gravity on the BFR spaceship? And I kind of want to kind of pull some things out of that, which is that simulated gravity in general, we just don't have a lot of experience in doing, at least in space, and it would be great to have more of that. But there's things that I think about that were not mentioned during the project or the presentation. Things like deep space operations. SpaceX unfortunately doesn't have any experience at the moment in deep space operations. They can send a vehicle to low Earth orbit, they can send it to geosynchronous transfer orbit, and they have sent a payload to L1 a little bit further out. But operating your own spacecraft in deep space, in a deep space environment, is radically different from operating your own launch company. So that's one thing that I feel like is still yet to be addressed by that there. I also feel like the transfer of cryogenic fluids in orbit is one that has not been addressed as well. Now, there has been fluid transfer on orbit before. STS-41G, which was a shuttle mission flown in 1984, was one of the first tests of actually moving fluids, like refueling satellites with that there. And it's been done between a couple spacecraft experimentally as well for DARPA and Air Force projects on orbit as well. But to me, those are still very big problems to deal with, and especially with the cryogenics, I heard nothing being talked about in terms of boil off. So basically, you losing the amount of cryogenic material that you have simply because of like insulation and radiative heat and other things like that. And it would be nice to hear about that stuff. I'm sure somebody's thinking about it at SpaceX, but it's really, these are things that really have to be thought about very thoroughly before you start chucking people to Mars. And I know that they're going to think about it. It's just a little frustrating to not hear things like that coming up. So.
To be honest, I don't know what sort of boil-off properties there are with methane-based engines, because we know a lot of, from the experience like with Centaur with what the boil-off is for liquid hydrogen and liquid oxygen. But for liquid oxygen and liquid methane, there's not a whole lot of experience with that and what there could be, at least not in the United States. Actually, not really anywhere, because methane rocket engines, are still, even though we've developed worldwide lots of different kinds, there's still not a whole lot of experience with that. So I would say that maybe the properties and what needs to be done in order to prevent boil off or to reuse all, to make sure that you can can use as much of it as you can, is that there just needs to be more studies, and there needs to be actual missions, and we need to better understand what it would take to actually do that. And I feel like the engineers at SpaceX and many other companies and government agencies know quite a bit more about that than we do. But I honestly have heard, and chat room, I'm relying on you to correct me if I'm wrong here, but I've heard that methane cryogenics actually have almost a near zero boil-off point, and clean with the hydrocarbons within it, clean all the tight tubing and everything like that, so that they don't get any blockages or have as much sloshing as you would with a hydrogen and oxygen system.
Yeah, I just a quick search of that real quick. The methane storage here on Earth, the boil-off rate is about 0.05% per day, which doesn't sound like a lot until you start adding that together and compounding that during the travel time between Earth and Mars, which I've heard 3 months is the ideal, but it would be a little difficult to pull that off. Liquid oxygen is a little bit easier to handle in terms of boil off. It does about 1/100th or just about 1/50th per day boil off. So a little bit less than I was expecting it to be. So that's good. But also a really good point made in our chat room just now by Shaky is that with big solar arrays, do you need to carry cryo hydrogen to Mars? Can you bring water instead and make hydro? I think it's a little more methane oriented because they want to take advantage of some of the chemical reactions you can do with Mars's atmosphere to literally generate your fuel from Mars's atmosphere. But that is a really good point, which is that there were studies done in the 80s and 90s at Marshall Space Flight Center to actually look at propellant depots and see if you can generate enough energy from solar power in order to actually be able to do that. And they said, basically, yes, you can. You can do that with shielding and general replenishment with that there. So very cool stuff. So really great stuff. Now,
real quick, that's one of those things that that ULA actually had talked about. You know, they're working on that ACES Advanced Upper Stage Cryogenic System, and they actually have a built-in, like physically a piston engine, basically a really high efficient engine that keeps everything pressurized and cool. Because some of these upper stages will be up there for potentially, months, years, or whatever, and you do have to take that into serious consideration. So I am very curious what SpaceX's plans are for that. And also, did you say though that methane has a boil off of 1/500th per day, and then oxygen was 1/50th per day?
So let me jump back real quick and just try to find that. So methane is 0.05% per day, so roughly.
0.05. Okay.
Yeah, so that would be one. Oh gosh, I'm having to do math on air. Hang tight with me here, everybody. I wasn't prepared to do math on a Saturday morning.
Let me get my calculator watch going.
Yeah, get out with it real quick. And then liquid oxygen has a boil off of, it's technically 0.016% per day. So yeah, so it's a little bit less than liquid or natural gas methane would get you with that there as well. So very, very cool. Now, Elon says that they want to get cargo flights to Mars in 2022, and as he noted in his presentation, that's not a typo. So that's what they actually want to do. And they also want to do the first crewed flight in 2024. Now, even though Elon said that those weren't typos, he also had the qualifier added on to that, which is that this is an aspirational schedule. So is this really actually realistic, or are we going to have to just tack on some Elon time to this? Who wants to start off on this one? You want to go, Space Mike?
Yeah, let me start off first here. I mean, with pretty much all the projects that Elon and SpaceX have undertaken, their goals have been very enthusiastic and hopeful. That's not a bad thing. By pushing themselves to do things like that, it's even though their goals might slide, and get pushed back, by having that sort of goal, I think that it allows them to dream big and feel like it's okay if we fail, but we should try to push for this. If we're doing Mars missions, we should be trying to send something every single time that there's a Mars window opportunity. And Me personally, I don't think that it will actually happen by 2022 and 2024. But if they work hard enough, they might have the capability to send it. They might not actually have the funds, but they might have the spacecraft in at least some form of construction and almost be ready. Instead, if they shoot for like 10 years out or something like that, then the people working on it today aren't going to have the motivation and the inspiration to make whatever breakthroughs they need to make in order to enable this plan so that we can see some sort of city like this develop on Mars. And I think I don't think that this is necessarily the point that he's trying to make, but I feel like inspiring the workforce, inspiring the people who are working on this project right now, today, is almost more important than having a reputation for being realistic, if that makes sense.
Yeah, it does. It does. How about you, Tim?
Well, I would definitely say, this is coming from Elon fanboy, definitely. This is the definition of Elon time to me, though. I just don't think. I mean, you're talking about not only developing a type of engine that's never flown on an orbital vehicle, a methane-powered engine. That could still take 2 or 3 more years. We have no idea. I mean, I'm happy that they're pushing really, really hard on it. I totally think it's the way to go. I totally think it's realistic that this will be the engine they're using. I think it'll scale up great. I have full confidence that it'll happen. But, I mean, these things always take time. Look at Falcon Heavy. I hate to use that as an example because it's not really fair. Because they made let me put this out there. They made the right choices by delaying Falcon Heavy until this iteration of Falcon 9. It would have been an absolute waste of money for them to develop and build a Falcon Heavy in 2014 with the vehicle, with the version 1.0 and version 1.1 Falcon 9. It would have been a disaster, not a disaster, but a waste of funds, a waste of money. So it's unfair to say, look at Falcon Heavy, it's delayed 4.5 years already from when they first wanted it to be online. That's not a fair conclusion, but we're still talking about so many new things, an entirely carbon fiber structure. We're talking about a lot of things that need to just be tested out altogether, and I just do not in any way see 2022 happening. Personally, I do, but I think it's going to be close. I think Space Mike's exactly right. I think we're actually going to be darn close to seeing them. They'll probably have some hardware starting to maybe move around. I just don't think they'll be Mars ready by 2024. I would love if if he went on stage and said we will have this thing flying by 2022, and not putting the Mars part of it, because that's still a big step. That's still a large, landing on Mars in 2022 is huge. We can't, we have to keep in mind how many people and entities and spacecraft have tried and who have succeeded to land on Mars.
One.
So saying they're going to land on Mars.
Only one. Only the Jet Propulsion Laboratory here in the Los Angeles area has successfully landed a payload on Mars. Or excuse me, let me qualify that. Successfully landed an operational payload on Mars. So because the Soviet Union definitely crashed or litho-braked quite a few vehicles on the surface as well.
Yeah,
so.
They have a lot of vehicles on the surface. They just aren't in one piece.
And Europe's Beagle 2 made it to the surface as well, but it had a problem and it didn't end up becoming operational as well. So, but the only
my overall summary is I just don't think 2022 is when they will be able to send a BFR to Mars. I would love if it's out and on the pad and flying around by 2022. I think that's realistic. That's 5 years away, though, still. That's a lot of work to do in 5 years. I could see it going to the next windows, though. 2024 would be the first cargo, first initial missions. And then if that all works out, great. And they don't have, that's the thing, don't forget, we might send them in 2024 in that first window uncrewed. But they might learn a lot of stuff during that first re-entry to Mars and first landing on Mars. They might go, oh, crap, we totally forgot. We have to redesign this, or we don't have the right this or this, the aerodynamic property is wrong, and have all those ships that we send in that first window crash. So there might be another 4 years or so, or however X amount of time to change what they learn on the first set, especially before they trust humans getting on board. So there might even be another uncrewed set. I think unless it goes perfect, say it just is absolutely perfect, and they go, holy crap, we sent 2, they both landed within a mile apart, perfectly, exactly as planned, everything was perfect. They're great. Sure, maybe then it's time to send people, I guess. But we'll see.
Yeah, I'm just gonna say it ain't happening in 2022.
It makes me think about 5 years ago, though. It makes me think about 5 years ago. Think about where SpaceX was at 5 years ago. I mean, in 2012, they had just had the first successful berthing to the International Space Station and haven't even started the official cargo missions yet. This was still in the demo mission phase. And Falcon Heavy was still just a speculative thing that may or may not be true. So, in that time, you know, they've had all these successful missions and have been able to develop, which hopefully will be starting next year, to have the first crewed flights to the International Space Station with Dragon, and also develop and have Falcon Heavy, which looks like it probably is going to launch this year. We're going to see that within the next couple of months. And that happened over a 5-year period. So even though I am, like you, Jared, I'm a bit doubtful that this is actually this will happen in 2022. I think that Tim is right that they could have the spaceship flying, and even if they do have the spaceship flying, just on a low Earth orbit test, I will still consider that a huge feat to have done in 5 years. So
absolutely. I mean, enabling 150 tons to low Earth orbit with a fully reusable vehicle, fully reusable, because the first stage will come back and spacecraft will come back. Fully reusable vehicle is going to be an impressive feat.
And just the size, like think about when that thing launches, that'll be incredible, period.
What
like
is it, 10.8 million pounds of thrust, something like that? I believe that's the revised thrust that's coming out of it. That's going to be a little more than a kick to the chest. Like, I hope people like get blasted back like Kung Fu movie style, you know, from 3 miles.
Something though interesting about this is the BFR is, you know, the Saturn V was 10 meters in diameter. BFR is 9 meters in diameter, so they might not necessarily have to build a bunch of new launch or ground systems to launch this thing. They might be able to do that from Cape Canaveral.
Well, if I remember correctly, the plan is to use LC39A as the eventual the pad for BFR. That was from IAC 2016, and they will have to take everything out at LC39A and completely rebuild that because the ground support equipment that they have there now is just strictly Falcon 9 and soon to be Falcon Heavy. So that will probably require.
You're right. Last year at 2016, they said that they would have to completely rebuild the thing.
Yeah.
But what I'm saying, they didn't really talk about that this time. And what I'm saying is they might only have to do minor modifications. I mean, it's still major upgrades, but instead of having to rebuild the whole thing, they might be able to start doing stuff there now, since it was already designed for a slightly larger vehicle.
Yeah, I think I don't agree with that, Space Mike. I think they're going to have to rebuild the whole thing because they're going to have to deal with not just a rocket taking off from it, but safing that entire area. And because Elon was talking about doing not just precision landing, but literally coming back and landing right back on the launch pad in the exact spot to get it ready to go. And they're going to have, 8 to 10 minutes to get everything safed in order to have the vehicle come back. And that, to me, is going to be a radical improvement of ground support equipment. And that will change the game for GSE completely. Because right now, the way ground support equipment works is that it's good to go for launch, but if you gotta if you have a launch and it actually goes, you gotta go out, you gotta check every little nut and bolt in order to make sure that your ground support equipment is ready to go for the next launch. And that can take that could take hours, it could take days, it depends on what ends up happening, because each launch, what it does to the launch pad is completely unique, because the atmospheric conditions aren't the same, and other parameters that you deal with at launch aren't the same. But I would be very impressed if they took LC39A as it is now and were able to very minimally work with that in order to get it to BFR. And these are things I love to be wrong about. So I got no problem being wrong about stuff involving
let me correct
the future.
you.
So
let me go ahead and let me try to make you wrong quick.
Go for it.
What I speculate. Don't forget. Essentially, if we look at Pad 39A and Pad 39B, which Pad 39B, the actual physical ground, the launch pad itself is capable of SLS, and SLS is a dirty rocket. It's going to have those massive SRBs on the side, those solid rocket boosters. It's going to be huge, and I think BFR is not that much, won't destroy that much more stuff as far as the actual the launch pad itself goes, right? Mm-hmm. So, and also we do know. So I think 39A could be configurable to actually be used for BFR. But the big rumor mill is that Boca Chica now is for sure already going to become a launch pad for BFR. I've heard that many times, and their new, however BFR ends up being launched, it looks like it won't have traditional umbilicals on it. It looks like they will be fueling and doing all of the connection to the ground somehow, like through the bottom or through the launch clamps and everything, and that goes all the way up to the upper stage even. So this will be a whole new system, and I'm thinking they're thinking refurbishment and how do we keep this thing rapid turnaround? You know, how can we actually turn this thing around quickly and make it a routine thing, as you know, as opposed to just hurry up and get this rocket off the ground. This is hurry up, get this rocket on the ground, land it, refuel it, and do it all again. You know, so it'll require a new system, and I'm sure they're working really hard to make that happen right now.
Yeah, and I'm wondering, those are excellent points, Tim. And as I said, I have no problem being wrong about things like this. I would love to be proven wrong about stuff like this, because that would change the game completely with it there. I am wondering, though, if Boca Chica is going to end up being the primary launch site, because if you're going to go to an equatorial orbit from Boca Chica, there's quite a lot of maneuvering that you're going to have to do in order to enable that. And I don't have the physics and math in front of me in order to tell me just how much of a hit, your payload is going to be able to take. Launching there, basically dodging countries in the Caribbean as you head to an equatorial orbit. But
it doesn't need to go to an equatorial orbit if we're going to the moon or if they're going to Mars. That doesn't matter. You can launch from Vandenberg and do a polar orbit if you're going interplanetary.
Yeah, absolutely. In fact, great example of that, the upcoming InSight mission from Jet Propulsion Laboratory is going to be launched from Vandenberg into a polar orbit and then on to Mars from there, and on an Atlas V 401, so the itty bitty Atlas. So yeah, I did not think about that. That is an excellent point.
So you don't have to straighten out and do an inclination change if you're leaving Earth's system. Yes, you don't quite get as much. Well, you don't quite get as much delta V. No, it doesn't really matter. It actually does not matter. You don't have to go
where you're
equatorial or anything.
Depending on where you're going to, you might not even want to be anywhere near equatorial orbit.
Yeah.
I mean, if you're going to Mars, you want to be slightly inclined to Earth's equator so that you're in the plane that Mars is in relative to the sun. Mm-hmm. So depending on where you're going, you might want to be in a weird inclination orbit.
Yeah, the ecliptic is not set along the Earth's equator. Basically the plane where the planets are in the solar system. And then there's also other objects that are out of the ecliptic as well, like asteroids and things like that. So you may, BFR may enable asteroid mining and things like that, for all we know. Yeah, that's a really good point. Also, I was just thinking, since BFR is so big and it has so much payload capability, you may just end up doing direct ascent to say something like the moon. I don't think they're going to end up doing that unless a customer wants that, because that's a significant reduction in payload to your target. But I feel like
they even showed plans of like how they would want to do their lunar missions, and I believe that they wanted to do at least one refueling while in Earth orbit.
Yes.
So that they could not only land on the moon but also return all the way back to Earth from that one refueling. So whether or not a customer would want a direct ascent and then stay there and have an expendable vehicle, so to speak, I mean that's a whole other thing. But if the vehicle comes back, they plan on doing the refueling.
So one of the surprises that Elon dropped at the talk this year was using the spaceship of BFR as point-to-point transportation for here on Earth. This is something that others have hinted at in different fashions as well, such as when we had George Whitesides, the CEO of Virgin Galactic, on the show earlier this year. He kind of hinted that Virgin's looking at something like that as their next step after Spaceship Two. So with everybody that is going to be playing in this game, like Blue Origin and Virgin Galactic, how do you think SpaceX is going to be with something this large compared to what everyone else is working at? Is point-to-point going to be something feasible for BFR? Or is this just a really, what do you guys think about this? Tim, what do you think?
What do I think? Well, I I think as again it kind of comes down to the scale of economics really. If you were to make this, say you're to do something like a Spaceship Two size vehicle, and you can only take 4 people on it, and all this, and have 2 pilots on board to do something like a suborbital point to point on Earth. I don't think that's actually as feasible as just going for something like this, where you could take 100 passengers, or if they make it a liner, look how big that thing is.
Yeah.
We're talking about not 100 passengers. If they just need to sit in a seat for 30 minutes and not have, cargo, like you would need to go to Mars to live, you're not moving, you don't need cabins, you could just have a seat. They could fit hundreds and hundreds of people. The scale of economics might end up being that this is very feasible, but the big but is it'll have to prove out massively, as they'll have a lot of practice if they actually are using these upper stages as tankers for each other. They'll have a lot of practice landing and taking off and doing all these things, and that'll probably have to have happened 100 times before, which could happen in a year or two. Who knows once they get it online? But it'll have to happen and be so routine that people are just like, yeah, of course I'd ride on that. Duh, that looks, they nailed. They're 100% in the past 2 years. Of course I'll ride that. But I think there'll be some public confidence issues, and a few other like high end things that we have to worry about, like how do we not make that a missile into another country and stuff. But Mike.
If I may, there's a couple other problems with this idea as well. I mean, first off, building those extra launch sites, even if they are on mobile floating platforms nearby cities like that, is going to be tremendously expensive. And let's not forget that it is currently illegal to fly rockets from one country to another. So they would have to change international law in order for a point-to-point transport system like this to even be possible. But I mean, again, a lot of the other companies planning point-to-point transport have the same hurdles if they plan on using rocket technology for that. So I just don't see it being a thing that, people would allow. Even if they were able to get through all of the red tape and get all of the regulations and permits and everything that they need, I think that people would still freak out. People like, say, in New York City would freak out, even if it's like 5 miles off the coast or something like that there's a rocket coming in, that close. So I don't think that it's something, just like Tim said, that the public would pick up on. That being said, if it was something that could be widely accepted and somehow get paid for, it potentially could be, the new business plan, as long as the times for it are actually correct. I mean, we know the flight times, could be under 30 minutes, at least under an hour, pretty much anywhere in the world. But how long would it take to get through the security checks? How long would it take to get ready for that type of flight? Would you need to go through, accelerated G training? Would you need to go through centrifuge training? Of course, you'd need to pass all sorts of medical tests and stuff like that. And, how far would it have to go? And how long would it actually take? If I have to prepare for 3 days to go on a flight like this, then I'm just going to hop on an airplane. You know what I mean? Like, it's not going to make sense to anybody if it still takes longer to go on a rocket flight than it does, a day-long airplane flight to get to another country. You know what I mean? So,
Yeah. I honestly
I don't
feel
know.
like
I have doubts about the whole point-to-point thing.
I have a lot of doubts too, because I feel like a lot of people who would want to be able to get from, say, like New York to Dubai in 30 minutes are probably not going to be willing to put on a intravehicle pressure suit, strap yourself into a 5-point harness, and then sit in a tiny little cramped seat, even though it will only be 30 minutes long. There's a reason why people pay $25,000 to have a literal apartment in an Emirates A380. It's the comfort of exclusivity, and to me, in spaceflight, there is little, if any, room for comfort. So it becomes very difficult to make for me at least, to make a business case, especially to get 500 people all at once who are willing to pay what it's going to cost. And I know Elon says it's going to cost equivalent to what it actually would be, but most certainly not at first. It will be a, mind the pun, astronomical price in order to get something like that.
Hold on, there's one thing that I think can bridge all this together is, don't forget, okay, first off, I have to respond to Mike's off the coast of New York thing, we're forgetting something. Hyperloop. Can you imagine getting in a Hyperloop downtown New York, going 100 miles out into the Atlantic where there's a pad, and you get there within 8 minutes? And I think the solution would be you're pre-trained, you're pre-certified, you're pre-checked to be able to fly on a BFR, and you train maybe a little bit, you do whatever you have to do. So it's something that you have, and then you have like hey, I can do this, so that they know you're physically capable. Maybe you have to have a yearly checkup or something. I don't think it's something where 3 days beforehand you have to get trained for every flight. It could be, think about the future. We have time to develop this. This could literally be at the time, people probably thought not everyone would be able to fly on an airplane, because you're in high altitude and it's kind of bumpy and stuff. Well, I think, if you're certified and checked out and everything's good to go, why can't anyone that can afford to fly on a BFR? And then I think it's just a drastic change. Just like people don't always see that the flying cars, or not flying cars, but self-driving cars are coming. Self-driving cars are coming. And I think once space planes and rocket ships are landing so routinely, it won't be this big divide that we have in our heads of like, oh, that's so far away, and all. It'll be so ingrained in our culture that it would be almost unfathomable. Like, you'd never go, well, why wouldn't I get on that? It'll be totally normal. That's just what I think.
Yeah.
Looking like 30 years into the future.
Yeah, I think it's going to be a little more than 30 years in the future. And eventually you're going to jump on a rocket and take it to somewhere on Earth. I just don't know if there's so many unknowns to be answered with that. But I look forward to seeing the answers for something like that. So just to wrap it up, I want to hear you guys' final thoughts. We'll start with Space Mike, and just tell us your final thoughts about the presentation and the stuff that we learned and the future of what is coming up.
Well, I still feel like this whole idea is still a bit of a pipe dream, but I'm also one of those people who like to dream. So I really like it, and even though it is still this kind of fantastic, far-out idea, I feel like it's started to get a little bit more realistic in certain areas. And I feel like as SpaceX continues with this idea and progresses towards realizing their goal somehow, that it's going to materialize as more and more and more of a realistic thing that we would all say, why haven't we had this before? Why didn't we have this before? This is incredible. And if Elon and SpaceX are willing to stay open to doing all of the things, then it might be able to enable all of these adventures that we want to see in our local system and in our solar system, in our lifetimes, that could potentially happen in space. And I want to see those things happen. I want us to go back to the moon. I want us to go to Mars. I want us to go on to the moons of Jupiter and Saturn. I want us to go explore the asteroid belt. I want us to be on Ceres. I want us to be everywhere. And of course, eventually get warp drive too. So I think that this would be that stepping stone. If this could actually happen and become a reality, is the stepping stone between our reality now and our potential Star Trek future.
All right. Tim, how about you?
So my overall thoughts is 100% I'm on board. Yes, this is fantastic. This is what we need to do as humans, is we need to just scale this up. It's kind of like there was that Sea Dragon concept a long time ago that was basically build it big and dumb so it doesn't matter if it's inefficient. Big and dumb and cheap so it doesn't matter if it's inefficient, This is almost like the 21st century version of that. Build it big and crazy smart and fully reusable so that you don't have to keep building new parts. You don't have to keep building new things. You eventually just have a fleet just like airplanes. And I say this all the time, and Elon says it all the time. Everyone says it all the time, and it gets so obnoxious. But it is just like an airplane throwing it away. And yes, we've had, way too many. We've had 60 years now of throwing away rockets, and we're now to the point where we probably don't quite have to. And I think this is their solution to how can you make the entire vehicle not need to be thrown away. And that's such a fundamental thing. It's such a no-brainer in the sense of like, of course that makes the most sense. And I think this is what it takes to do that. It takes this scale. It takes this crazy construction. It takes this mad, big, huge dream. And I'm all for it. I don't know if it'll happen as quickly as we all hope, but I will be patient and I will be cheering along on the sidelines the whole time. Absolutely.
Yeah, and I guess to kind of summarize my thoughts on this, there are a multitude of unknowns that are going to have to be addressed sooner rather than later. But those are unknowns that we've known about since the 1980s. Nobody has attempted to take on these unknowns. So we really are going into truly unexplored territory with VFR and the architecture and getting people to Mars. And I feel like if anybody is going to be able to do it, it will absolutely be SpaceX. I don't know if they'll do it in the timetable that they're expecting. I don't know if they'll do it with the same success that they've had with developing reusable rocket technology. But I can't see any other group better to do that than the group that they have at Hawthorne and their various facilities all around the world. Those are the premier people for what they want to do, and they've got the right people doing the right things at the right time. It's kind of everything's coming together to finally make that
dream team.
The dream team, the thing that people have been talking about since the 1950s, which is getting people on Mars. We're looking at the genesis of that finally. It's very exciting. There's a lot that we don't know, but at the same time, it's too exciting to not be optimistic about it with it. So very cool stuff. All right, thank you, Space Mike and Tim Dodd, Everyday Astronaut, for coming on the show today. And we are going to take a quick break, but when we come back, comments from last week's show. So stay tuned. There's more tomorrow in just a little bit.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end.
T-minus 1 minute.
We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
And welcome back. I was just discussing I might need a battery for my ear because apparently I'm on red. But first, before we get to that, I want to make sure that we give a thank you to all of our Patreon members. These are people, of course, of the escape velocity variety. We have spoken a little bit about them. We, of course, then move on to our orbital variety. We've also spoken a little bit about them. What you haven't heard yet is about a suborbital variety. These are the $2.50. Plus, they also get their name in the show. Thank you, thank you, thank you. Exclusive access to Patreon-only hangouts. Lots of other things. Oh my goodness, so many things. I will talk a little bit slower so you guys can find your name on the screen because I know that's a very exciting thing.
Don't forget to circle it with a Sharpie.
There you go. Yes, well actually, no, it's a really terrible idea because as you continue to contribute more, you actually move up in the screen a little bit. So don't do that. You'll have just lots and lots and lots of circles. In any case, if you are also interested in getting your name in this show or others, or maybe not this show, I suppose, but other shows, head on over to patreon.com/TMRO. All right, so if I start sounding really gravelly, we'll have to figure out a battery situation. Maybe we'll have to make Kat go grab it for us. In any case, we are here to talk about comments and questions about last week's show. I am speaking a little bit faster because this has been a show, and I want to make sure we still continue to get to comments. But last week's show, episode Orbit 10.35, Mr. Jared here did have a great interview with one Skylab astronaut, Jerry Carr. If you missed that, please Go back and find it. It is really, really, really good. Okay.
Yeah.
Oh, goodness. I got all of that out of the way. Great. So now, Capcom, that's me. I'm going to continue on with our very first comment. Well, because Ben always, refers to me, and now I kind of have to do it on my own, right?
Ready,
So-
Capcom?
Yes, I am. All right. First comment comes off of Patreon, actually. We were just speaking about that from one Joseph Habdank. I hope that's actually your last name because that's really amazing. Says, Ben is wrong. Oh, there you go. Thank you. Ben is wrong about us needing to be on other planets. We can build spaceships with artificial gravity, rotating habitats, and you could possibly have millions of people living in them on orbit of the Earth, Moon, etc., with healthy 1G, I almost said 1 gravity, 1G of gravity, never needing to colonize or terraform other planets. I think we always like to call Ben wrong, so that's just...
First of all, good start to the comment.
Right, as far as I'm concerned, absolutely. I don't know enough about. I will openly say I don't know enough about this topic to say whether or not Ben is wrong. I just enjoy saying it. So if any of
If
you
I
guys
could jump in here, I feel like we need to do both things. To respond to Joseph, I feel like we need to have those independent colonies that have artificial gravity and everything like that are essentially a really, 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 really big space station. But I think that we also need to colonize and terraform other planets as well, just to build up experience. Because, I mean, even if we do have something like an O'Neill cylinder or something like that has artificial gravity, there's still lots of things that could go wrong. And personally, thinking thousands or even millions of years out, I personally would like to go to another star system, find or terraform a planet into near Earth-like conditions so that we can just survive and live and not have to worry about maintaining the ship, so to speak.
Yeah.
And planets and like the moon offer the chance to go underground and have a safe haven from radiation and micrometeorites and all those types of things. A lot of the things that are really bad out in space, at least if you're on a body, you can tunnel down and actually do that, and so that's a good argument for why planets as opposed to just space stations.
Yeah, and
it's not just about gravity.
Yeah, we need to do both, though.
Yeah.
We need to do both, though.
I was just going to say, this commenter has obviously read The High Frontier by Gerard O'Neill, which I highly recommend to everybody. If you're really interested in getting humans off of this planet, that is a book that you need to sit down and read from start to finish. And just don't sleep, don't eat, just read straight through it and understand some of the really great ideas in that book. So, yeah.
All right. Also recommended by Vax Headroom in our chat room as well.
There you go.
It was just funny. I was like, oh, yeah, it says right there. All right, awesome. So next comment comes off of YouTube from one Peter Arnold saying, Jerry's memory of all the events during his career was amazing. I loved his really intellectual answer to the question, why space? That was a great answer. Tim Dodd, did you get a chance to see that particular episode?
I haven't.
You should. It was probably, I think, one of the most eloquently worded answers to that particular question.
Mm-hmm.
I think at some point we need to have just a compilation video of our favorite why space answers. I think that would be really cool. That was really great. So if you missed that one, please feel free to go back to our last week's episode 10.35. That was it was a great interview. Jared, you did a really great job. Jerry was, again, one of those very easy people to interview. Really fascinating stuff. Great storyteller. Yeah. And
I learned a ton
Yeah.
from that interview, and that's really when I can tell that a guest is awesome, because I did a ton of research on him, but I still learned so much from that interview. So I think somebody in the comments, like one of the first comments we got on that episode was like, man, it's really great to hear from someone who is actually there. You know?
Yeah.
So like, it's pretty cool that we were able to do that. So,
Totally.
Yeah.
All right, so next comment also comes off of YouTube from R. Instro, saying, regarding mass drivers, I prefer the idea of orbital rings / orbital launch loops over most other quote-unquote futuristic options for getting out of a significant gravity well, like Earth, Mars, etc. Unlike the other technologies, political war, willpower, and financial expense are the only obstacles standing in the way. Humans are capable of building these with the materials and technologies that we already have. Again, not my area of expertise. If anybody else wants to chip in and comment on that one. No.
Well.
Awesome.
Well, my internet connection's getting a little slow here, so I apologize if this is choppy, but I feel like that would be an even bigger architecture, an even bigger engineering feat would be those type of orbital launch rings. And I honestly, when it comes to the moon, I just feel like we'd be fine with rocket technology for quite some time to come. Doing, an orbital ring, or even doing a mass driver or a lunar elevator, I feel like is stuff that would be such a huge engineering project that is not something that I definitely won't see in my lifetime unless I become a robot who lives forever. So,
yeah. Which we all will.
Yes, eventually. Just upload me already. So, yeah.
I hope.
Oh, that's hilarious. Jared, anything else?
I just feel like there's a lot of breakthroughs that need to happen in materials at the moment. I know everybody, this is sort of in the same vein as space elevators, which everybody goes, we've already got the materials to do it. They've made carbon nanotubes. And they're like, yeah, we've made like a handful of carbon nanotubes in an ultra clean, super precise, incredible conditions laboratory.
Well, and they're like this big.
Yeah. We'll just put trillions of them together and string them together.
Right, like we're not getting very far with this, man.
Yeah, I mean, I'm not saying it's never going to happen. It's just right now, is it here? Nah, not quite. So yeah, the materials we're just barely beginning to get the type of materials that can enable things like this. But also, if I don't know what the cost of a actual orbital ring would be to go around the Earth, but I imagine it would probably cost more than the entire global economy. Like an order of magnitude more than that. But also, I don't know as well. I'm sure somebody in the comments will angrily correct me, which is perfectly fine. So give it a shot.
As Andrew Shire so eloquently puts it.
To $4. All right. Sounds good.
Well, that's the $4. The dollar sign is just 4. Anyway, okay, moving on. All right. Also, I do need to mention really quickly, with both of you guys that are on Skype, and you cannot actually see one another, nor can you see us. You are doing such a ridiculously fantastic job at looking at us and each other when either one of you is speaking. It's so dumb natural that I almost forgot that you couldn't. So good job for both of you on that one.
Thank you.
Got the old pro here.
I know, right? You're learning everything off of his shoulder. So
doing
next,
a really good job, though, Everyday Astronaut.
Next comment comes off of YouTube from Landy. I'm going to just say it's likeness because I'm just going to prefer to say your name that way. Says, with failing launch costs, would it not be cost effective to mass produce dozens identical of or modular exploration probe / satellites? It seems that the instruments would be similar for different targets, and aren't communications satellites going that direction?
Sort of like a modular probe or exploration of the solar system?
I mean, to a certain extent, like some parts do kind of need to be the same, right? You're going somewhere, you're going to need this. You want to look at something, so you need one of these, and you need, to have batteries, so you have one of these batteries, and you need, solar panels for that. So here are the solar panels. That it feels like you should be able to plug and play on some of these things, no?
Yeah, actually, NASA's Jet Propulsion Laboratory in the 80s proposed a program called Mariner Mark II, which was going to be essentially a low-cost modular spacecraft to do scientific exploration of the solar system. And there were initially 2 missions proposed, which was Saturn Orbiter Titan Probe, which eventually became Cassini, and Comet Rendezvous Asteroid Flyby, which was CROF, which actually eventually became Rosetta with that there. And things were going great with those programs until the early 90s. Congress was basically like, no money for this. So so it was kind of more not that it didn't want to happen, but it was that the political will kind of impeded it from happening during that time period. But I would imagine, especially with communication satellites, with like large broadband constellations that like groups like SpaceX and other companies are talking about, there is going to be definitely be modular development of modular plug-and-play spacecraft.
Right.
So,
I think though one of the things, especially when we're actually talking about like different bodies in different points in space. One of the things we have to remember is we don't want to fall into like the F-35 jet category where they're like, well, we'll just build one jet for the Navy, the Air Force, the Army and the Marines or whatever. It'll just do it all. And then it ends up being crazy expensive to actually try to make something that's best suited for every situation, So I think when you're talking about exploring different bodies with different gravitational fields, different amounts of radiation, why would you, if you're exploring Jupiter, you need a huge radiation vault for all your electronics, but you wouldn't need that on, say, some other body in space, And so why would you send a huge, heavy titanium radiation vault to Mars, when you don't need it? So it's good to have commonality, but these are still very specialized pieces of equipment that do need to be focused on not only the body they're visiting, but the budget that they have for the whole program, because that can even determine how big the rocket is. How big the payload is. So how big it's all exponential. So it is sort of a slippery slope,
And maybe there needs to be. Go ahead, Carrie Ann.
Are you sure? The chat room is saying, like Johnny Boy was saying, CubeSat and big size, and I think Jazz Throw also said something along those. Yeah, CubeSat. Something along those lines. I mean, I guess that's kind of where that sort of area of our industry is kind of going to and coming from to a certain extent on that. But Mike, what were you going to say?
Well, especially a lot of the communication satellite makers and builders are having standardized, classes of spacecraft, if you will. And even Lockheed Martin came out recently with this is their new standardized series of spacecraft that they have to offer that are modular and can be designed for whatever mission you want. So I feel like I think we're talking about NASA here with, interplanetary probes and, the type of agencies that are undertaking science missions like this. Wouldn't it be nice to have different classes, though, of these type of probes? Have the Voyager / Cassini class probes for the outer planets and stuff, way far out in the Oort cloud. Have, a terrestrial class, that's standardized and modular. And I think that we're seeing that. And we might see something like that happen with probes and satellites that are headed for interplanetary missions. But Sam is also right that each mission is specialized. And so wouldn't it be nice to have that kind of modular system of, we can build it in such a way that all we have to do is add, radiation protection that would be simple and lightweight, that could be some type of plug-and-play system. I know I'm oversimplifying that a lot, but it would be cool. But whether it's something that we need to have, I don't know.
NASA kind of already has something like that, because NASA has their Discovery program, which is sort of like these lightweight, very small, low-cost, rapid. But
they're not the same spacecraft bus, though. They have the same type of weight limitations and maybe certain the same instruments that they contract out for. But most of the contractors who build the satellites for the Discovery program and even the Explorer program, which is still going on, are very different.
Yeah, that's correct. And even with New Frontiers and Flagship, every probe is kind of
each one is unique.
Form follows function, if you will, in designed for explorative spacecraft. So yeah.
All right, awesome. Well, I think that was enough conversation for one day, yeah? But I do want to make sure I give a last thank you to some more patrons. I know you didn't think there was more, but there definitely are. These are of the ground support variety. These people have given us either somewhere between 1 penny up to $2.49. They, of course, get a thank you, a shout out, and their name in the third segment of the show. They do also get access to our exclusive Patreon-only hangouts and early access to After Dark as soon as it is available online, which is really great. So again, every single penny helps. We appreciate you. We appreciate every single one of these people. And even if you don't have a chance to contribute to us, we still appreciate what it is that you do with and for us. If you are interested, though, in getting any of these goodies and more, like Jared was saying earlier, you can always head on over to patreon.com/TMRO. Whew. Right? I think that was good. That was good. Speaking of After Dark, that is what's coming up next. If you're watching us live, feel free to continue to participate with us and joining in the conversation. And if not, that's okay too. We will just go ahead and see you next week. Bye. Bye-bye.